Hello, we're going to be programming a neural network. I wouldn't really call it a library, it's more just a very small class in Javascript. So I've been using this as a test ground to... Oh, wait, hold on 1 second. Just gotta do something. Actually forgot to open it. Alright. Here we go. Alright, so right now I'm just testing it with a simple triangle wave. This is what I always start with testing. Then I'm going to do a little text generation test maybe. I'm not sure. I've actually been thinking about some different tests that I could do. But we're just going to start with this simple graphing test. The triangle wave, if I get it working, I think I might add some other functions like a sine wave or something. So what I've been trying to do differently this time is to train the output layer, I figured out that you can just train the output layer with the derivatives perfectly, just with no what's it called? Basically, like, it's not convoluted at all. It's the derivative is the direct error, so you can training it is perfect. But the bias, so this actually has no bias. That's an interesting thing I found, is the bias actually blurs it almost, because it has no like the states being different each time makes this train properly. It's actually some really complicated stuff. But then the issue becomes training hidden layers. How is this working? Seems like it's working alright. Okay. So what I was doing before is evolution to train them. I had a system down here that searched through it in like a grid. What I've been thinking about though is that this can almost be thought of like a distance function, or like it's hard to explain, but like the loss function could almost be viewed as a distance function, I believe, and you can calculate the derivative. So basically what I'm going to look at doing is like ray marking towards the surface. This is some funny stuff. I'm trying to apply ray tracing to the neural network generation. Okay. So to calculate the normal or the derivative, which gives us the direction towards the lowest point. See, this is the thing that makes it the same as the distance function. The same thing about with the distance function, the surface, the lowest point, 0. With this, the surface you're looking for is the lowest point, 0. Like, it's so interesting. Hey, Morame, did this say gay? Oh, now it did. Hey, Kappa. Alright. So I have an axis -1 here to represent when it's starting. I don't know if I'm going to need that. I'm resetting that to 0. The axis is basically... I should actually rename that node. Distance function. What? Oh my god. Wait, let me try this again. Distance function. Oh, it actually got it. Nice. Alright. I had someone come in here the other day and tell me that this thing was horrible and it wasn't accurate at all and that I shouldn't use it. Actually, not the other day, because I hadn't streamed for a while. It was like, oh my god, like a month plus ago. But like, it gets more than 50% of the words correct. You know what? I would say it gets more than like 80%. Look at this. It got 80%. It got all that stuff. And then this guy came in here and all the stuff he talked about was with like the most broken English and grammar. And it was just like, yeah, man, the caption thing is so bad at English, Kappa. So this should actually be node. Then normal is going to be a float 32 array. Grammar. Gray AMR. Oh my god. That's good. Alright, so normal is going to be a float 32 array. Node count. I'm gonna need a base loss. So this actually might be -1 would be the base loss. So I might not even do a range. Because this should just search for it. It's on YouTube, how an English teacher walked to some street market and mark error in every ad. Oh my god. Jesus. I feel like that's like if you went around, there's like a bunch of the signs where you only have certain letters, so they end up using like incorrect letters to make up for it. And I feel like that would just be like if a person went around and corrected that, they would just be going like easy picked fruit. My English is absolutely horrible, and I hope you're not too mad because it's absolutely fine. You can understand what everything is. And like, you spell things wrong sometimes, and I can't tell if it's because like sometimes you just mistype things. Even people that are perfectly fine with English. Or me with programming. Smiley face. Alright. So what I need to do here is, if the node is 0 or -1, then it's just gonna search at the base, which is just the transform itself. So it's gonna do nothing. It's actually gonna do nothing here. Wait, so if it's not -1, if it's bigger than -1, hey Druid BR, I'm working on a neural network for JavaScript.
Infinite power.
I'm trying to figure out the best possible way to train the hidden layers. I'm looking at using like a ray marking type method where you find the direction, the normal to the surface, which is the lowest point in the gradient, and ray mark towards that. That's great. Which framework are you using? No framework. This is the neural network right here. These are the hidden layers. This is the output layers. It has no biases in the output layer. It's just all rectifier activation functions. I also have like I also limit it to like 10,000 just so it doesn't overflow to infinity ever. Oh man, I call this transform, but I feel like I should call it something other than transform. I don't know what a good... I feel like run neural network isn't right, but technically it transforms the state. So I'm going to keep it at that. Keep it up. I will, dude. I'm hoping to get this working. Oh man, I haven't been streaming these past few days, but I've been working on this like a little bit on the side, and I've been like, shit, I probably should have started up the stream and been sharing this. It's working really well right now. I should have showed this old version that just searches through the grid across a range, and like in 1,000 iterations it trains it to like hold on, fucking head is to 1% accuracy, which I think is really good. Before it was taking me like 7,000 iterations to train it to that accuracy. Man, neural networks are expensive to compute. So anyways, each of these node indices is an axis on the normal. So I have to offset the node for each of these by the base loss. So actually, wait, let me do this first. Okay, when it submits, if this is -1, then it sets the base loss to this. It's also going to increment the node. I'm going to keep this part right here that saves the best loss. Tried to once work on a neural network with a friend that can handle it. It's tricky. Technically it's calculus, so that scares a lot of people. Alright, I'm calling this transform here. I gotta rename this. Here we go. Hire some Twitch streamer to make a neural net for you. I already have a C# neural net library. It actually uses probably better code than this. It uses Adagrad. It uses actual, like, tested math. I'm trying to do my own shit right now, but go to my website, Ethan's Neural Network. Examples. This simple function is basically the same thing we're doing right now, of mimicking a triangle wave. So this neural network trainer does Adagrad. And I can't remember how many iterations it trains in, but I think it's pretty good. But it's still not that good. I'm not really interested in neural networks that match. Doing fine with me. Yeah, I like doing things myself too. Alright, now I gotta rename all this. Good luck, dude. Goodbye. Have a good night. Good Druid BR. Alright, so what we're going to do is we're going to offset each node or axis by the base loss. Just one by one. And we're going to measure the loss for each of these. That's going to be this normal value. We're going to subtract the base loss from that. That's going to give us the normal or direction of the gradient. We're going to follow that to the bottom of the gradient. That's the plan here. Oh man. Then the difficult part is though, wait. So an issue that this is actually going to have is this can get stuck in a false minimum. Oh man. So I had this other method before that I ditched, that I just erased, that was actually like a quad tree or octree type search. I should have saved that code. That might actually be better, because that won't get stuck in false minimums, it'll just keep going. Like with this, then I'm going to have to add code that detects when it gets stuck in a false minimum. Oh man. Taxol. Okay. So like the octree search was inspired by this grid search. It's basically like the subdivided version of a grid. which is subdivide and conquer is always the best way, I think. So I think I'm actually going to do that. Because once I do, when you do something like this, like worrying about getting stuck in a false minimum is absolutely like brutal. Because then you're basically trying to detect if it's not going anywhere. But detecting if it's not, like, it could be stuck in an area where it just keeps going around. So you think it's moving, but it's actually like stuck in like a tunnel, so to speak. It's like, oh man. So yeah, I'm gonna go back to the search. I'm just thinking, is there a way that you could do this to get out of the false minimum? Like, what if I added some random jitter or something? Nah, yeah. That's just going to be a question of adding such a large value that gets it out. Whereas, that's the good thing about the search method, is it just naturally goes and searches over in the next part of the grid. So, yeah. Let's go back to that. Alright. So this is pretty complicated. This is one of the main things I've been thinking about. It's basically each bit in the uint32 is a different leaf bit in the one-dimensional tree. So imagine if the range is 1 is between 0 and 1, then I should actually do min range and max range. If it's 0 and 1, then like the first bit will be dividing the whole range in 2, so it'll be like the 0, it'll be like 0.25 and 0.75, just like the two divided point, the two center points of each subdivision. And then if you picked one of those, it would be dividing those in 2. And oh man, so yeah, I'm not even going to try to explain this, I'm going to be honest. I'm just going to program it. Sometimes I think code just explains things best. So the search is going to be have the number of node counts. I'm also actually going to need another uint32 that says if a leaf has already been searched. So that's why I multiplied it by 2. So then if this is -1, we're going to initialize all the nodes here to the minimum range. Oh yeah, and I got to set the range values here. So the reason I'm writing this in JavaScript is, first of all, if you can see here, the neural network itself is like 50 lines. Like JavaScript, you can write a bunch of code, and you can write a lot of stuff in a very small amount of code. So it's good for testing, I find. And I actually want to make some little neural network web apps where you can like hopefully throw in some images and transform them. Do some like text generation, maybe even some audio generation. So that's why I want to make it as like a JavaScript library, so I can make some simple web apps that everyone can easily access. Just like how I made like the blue noise generator. Alright, so I think alright, I gotta actually init value is gonna be how am I gonna calculate this? I believe it's actually this dot min range plus this dot max range minus min range times that. So this is going to initialize the hidden layer first of all. Actually, wait. I should actually make a function for this. What am I doing? Because there's probably going to be a time when I'm going to want to do this anyways. Okay, there we go. So that'll reset the search. And that way I don't need to have this initialization function there. So what is it going to need to do here? So what I could have it do is have it reset. Okay, so it needs to try each half of the subdivision and then choose which one it's going to take. So search loss. And then I don't know what I should call it, maybe search side. So 0 is going to be the left side, or smaller side, negative side, I don't know. And 1's going to be the positive right side. Alright, so then here, I set the node value. So what I'm wondering is, I don't think I need to recompute this the whole time from the search value. I think I can just add the offset to this as long as I reset it each time. So I guess I'll just add to it. So I think along with the search depth, I should have search, I don't know what to call it, search scale, search value. Basically the max range minus the min range. Alright, so actually if this is initialized to this, don't need to do anything here. Okay. So I'm going to go through this step by step. So if this is already initialized, initial value here, then when it submits, it's going to check if the loss, it's going to do this, check if So then we need to go into this. Actually, I'm going to save this as wait, how am I going to do this? Okay, so search NI to enable or flip the bit, it would be XOR. Okay, actually yes, I'm gonna have, oh man, integer operations in JavaScript are like, oh man, they're horrible. They don't work properly. Look at this shit. So you can't even use, so numbers in JavaScript have like 64 bits or like 56 usable or 54, but in bitwise instructions you can only use 31. You can't even use 32. It bugs me so much. Look at this crap. So 31. Oh wait. So negative. So it uses signed numbers for the bitwise operations. And if you go past 32, it doesn't even work. It doesn't even use full. Oh my god. Oh, it hurts. It hurts. So yeah, actually you can use 31 bits. It just doesn't work as unsigned. It's man, it's really some shit. So I'm gonna need I think I'll call it XV, XOR value. So for this, on the right side, the XOR value is gonna be 1 by the search depth, like that. And I'm also going to need to mark, I believe that I've searched through here. I don't know. I'll do that afterwards once I see that I need it. This should be good to start. So this saves what side was chosen. So then here we can increment our node value. If ni bigger than equals to, oh, classic. Let me plug that in. Alright, man, one thing I also want to think about is, so the one thing I liked about the normal method with the derivatives is if what you're searching for, the surface is changing, because for example, if you're doing like a generative adversarial network, it's going to be based on the other network you're training. You need it to actually work with like a moving thing, but the way this search works is it expects once it's searched like a cell, it doesn't need to go back there because it's already searched it, so it doesn't actually work that well with moving things. So that's one of the reasons I'm actually looking at like a grid search like this, is because it's like rough, and you could get like a rough idea where it is. I don't know, but technically the octree, I believe, is like the tree subdivided grid is just the optimal way of doing the grid search. So I'll stick with this. this is bigger than or equal to the node count, then we've gone through all the nodes, we reset it, and we increase the search depth. Then we also need to check if the search depth has gone to the max search depth. So what we can do is if step bigger than or equal to just on max search depth, then we actually need to start going backwards, and that's what we have these bit values for, this extra set of bit values. This is the part that is going to be very confusing for me, because it's going to be basically doing recursive search without a recursive function, because it's a much more efficient way to store it in bit flags than if you did it as a function. It would be allocating it on the stack, and it would be absolutely brutal on memory. So that's going to be the key part of this, is programming it to store the search results in bit flags in the search position. So, oh man, I actually don't know how this is going to work. Like, once it hits the max depth, I guess it goes backwards and tries the other option. I gotta think about that. I don't need that best side option. So I'm just looking here. I'm actually not resetting the search side either. I need to do that. Search side equals 0. Okay, yeah, so when this hits the max search depth, it should actually go backwards and lower the search depth by 2. And then it should actually go and search. So yeah, this is definitely going to be what this is going to be for. It's going to need to memorize if it's gone backwards on the search as well. Okay, so this and I make the node count as well to do the stride of this. So n count plus ni is going to be the node. Wait. Oh man, do I only need one of these? Wait, I might actually only need one of this. I might not need to do this for each node. Let me think about this. Because I believe when it goes backwards and has tried the other Yeah, okay. So that's going to mark that it's been searched. So then when it hits the end, it's going to want to go backwards to it's going to need to reset this. No, yeah, the search is going to be different for each node. Yeah, actually, okay. I actually should try the normal direction. One of the things that I've been thinking is because I've already handled the output layer with this training function, is that I don't need, like, okay, so the thing, I should actually, you know what, I can actually visualize, I can visualize this false minimum. So, this loss has like a gradient across all of the neural network states. You're trying to find where the loss is smallest. If the loss is 0, it means the neural network is perfectly matching whatever you're trying to model, whatever function you're trying to model. So, let me draw a gradient here. So imagine, that won't do. Wait, is this not? Okay, I'm stupid. It's white. Here we go. Okay. What the hell is that? All right. Okay. Let's say it finds the gradient here. This is a terrible example. Okay, so first of all, this actually shows an issue with the gradient problem. So these white areas where there's barely any gradient, there could be a completely flat area where it just can't measure the gradient. It's gonna, like, you're gonna have to randomize the search extents a huge amount to find that gradient. And then, for example, let's say it's like right here. So it goes, okay, the gradient to the lowest spot goes over here and it follows it here. And it hits this point where all of a sudden it goes here and it goes, wait, going that direction, raises the gradient a whole bunch. So even though the lowest gradient is over here, it's like not taking that jump, because it just follows the lowest gradient and it doesn't like that's the super difficult part, is getting it to. So this is my whole idea with this octree search, is it'll actually like split these in half, and it'll go and test each side and go, okay, which one, this one is closer. So then it'll take this and it'll subdivide this into, this is actually like binary space partitioning as well. So it'll subdivide it here and here, it'll check here, and it'll find that here is smaller. So then it'll take here and it'll subdivide that into like right there and there. It'll find that here is smaller. Then it'll take here, subdivide it here and here. It'll probably find here is smaller instead of there, and it'll like go and search in there, find out. It won't find out. It'll like find the best it can find in there. Eventually it'll go out and go trying in here because it's recursive, and it'll go backwards. Then it'll subdivide in here, and it should eventually try this subdivided spot here, this being the smallest. But then the whole issue is if this is moving, if this lowest spot is moving, oh my god, if it's moving, then you're fucked. So that's actually one of the things I'm thinking about right now, is if the gradient function right here gets stuck because this is still, but it works better if this is moving. I could actually fix it from getting stuck if I shifted this around. So if I kept it in the same spot but like shifted this so that this is actually up here, that would just technically be like random generation though. So yeah. Anyways, I need to figure out how I'm gonna check if this has already been searched. Or basically like it gets to the bottom here, it goes backwards, and it should actually step through multiple times. I think neural network should do all the work by itself. It's already optimized to calculate if the best part is correct. That's the thing though, is it actually doesn't optimize itself. It's all about your training function. Like before I was using Adagrad, which is the same sort of gradient thing, adaptive gradient. Adaptive gradient algorithm is a modified stochastic gradient descent algorithm with per parameter learning rate. Yeah. RMS prop, I believe, is like the best thing right now. It's a method in which the learning rate is adapted for each of the parameters. RMS prop has shown excellent adaptation of learning rate in different applications. I'm just telling. Yeah, adaptive moment estimation is an update to the RMS prop. Natural gradient descent. Kalman is an online and offline. Interesting. Second order methods. However, directly determining the Bayesian matrices for optimization is not possible in practice. Shit. This stuff is so complicated. Okay, so what I'm actually going to do, I figured out, is I go in a while loop here backwards through this, checking if the bits are set. So actually, I'm not going to set this last search bit here. Or actually, wait, this is never going to be used, so it doesn't matter. Let me make sure the battery's good. Okay, yeah. So this is, yeah, actually, wait. So if this goes back to while, I should actually have this. This is a variable because I'm using it so much. Yeah, wait. So this is going to go through. See ya. Good night, Morame. Have a good evening. I'll hopefully be streaming a lot more over the holidays, so hopefully we'll talk a lot more. I'm going to go up and get some water now and stand up. I got to think about this because this next part's going to be key as well. So I'm going to stretch my legs, think about how exactly I'm going to do this while loop and parse, go search through this tree. Back in a few minutes. So this is actually 1.2%. Let's actually divide that by it's actually out of 11. I forgot, so it's actually a bit better. So I'll divide it by 11, so it's actually normal. We're gonna do 100,000 0.003. So you know what? That's actually pretty damn accurate. And then let's try increasing the grid precision. That's super interesting. Actually made it worse. Let me make sure I have this right. Resolution. So making the resolution 100. So let me test this. 5, 2 trains it really well. Oh my god, why is it training so well? This offset, point sampling offset, must be pretty good. So first of all, I think I need to offset this, because right now subtracting range from this is making it based off negative range and not truly in the center. I don't know how to explain it. I think the solution is to actually do plus 0.5 right here. Yeah, actually, so that's what the offset does. Alright, so let's see how changing the grid size affects this. So 4 makes it better. 8 makes it better. 16. Not as much of an increase as 8. Yeah, so 32, subdividing the grid into 32 is actually worse. That's so interesting. Let me think about this. 10 divided by 32. That's not even that accurate. Minus 0.5. Yeah, not even that accurate. What? How is that working better when there's 100,000 iterations? So let me think about this. It searches through 32 positions, selects the best. 32, so the 100,000 would be divided by 32. 100,000 compared to... I wonder if it's literally just the increased iterations of searching. So also this derivative method, I believe it only works if oh man. So I'm actually wondering if, since it's using these linear, completely linear neural network, like it's just a single layer, it makes me wonder if it could train with the derivative, or if there's no, because I actually think that the false minimums and like that non-uniform nature comes from the multiple layers, and when you just have a single layer, If not, I'll figure out some ways. I have some other ideas, like, what about making the neural network like almost quote unquote fly around, where it follows like a curve, almost trying to triangulate the loss gradient where it moves each time, so it would never be completely accurate, which also means it shouldn't get stuck in these tunnels because it's never completely accurately following the gradient. But it should still fly around following the shape enough. So that's kind of why I want to look at these gradient methods. I'm also looking at doing it just in the neural network class here, not in a separate neural network builder. I can definitely take this train function at least and put this. Alright, I'll be right back. In just a few minutes, I gotta go to the bathroom. Question is though, what derivatives of the derivatives would you do? Or what are the second order derivatives? In this case, I guess it would be the amount that the derivatives are changing. Huh. Let me try dividing this by TLV, just for shits. That actually made it better. Wait. Oh, no. I'm actually not sure. With these really small numbers, it's really hard to tell if one's smaller than the other. Huh, so I think that is actually a smaller value. Wow, wait. So does that mean smaller training rates are better for larger iterations? And I can actually look at the nodes like this. So it's nearly perfect. There has to be a way to do this quicker. I wonder if lowering this over time, like if I went minus I divided by 10, so the derivative actually goes down over time. No, that made it worse. I'm just thinking I could create an array and store the second derivative of this. I'm just thinking how I would use it then. Maybe use that to shift this. Let me just think about this. This is multiplied by the state. I might actually multiply the state here, or multiply this and then calculate a different derivative for each weight. So this is actually what the builder is nice for. So I may actually do this as a class. Let me think about if this would actually work though. Derivative from what I'm calculating for the triangle wave, second derivative would be basically nearly identical to the first derivative. Yeah, so I feel like if I do the second derivative, don't multiply it by the state here, it will the derivative will not properly be lined up with the state. Because like if you multiply the second order derivative by the state here, it'll be multiplying like the data from the derivative from the old time with the new time. That's why I feel like you do the derivative right here. Let me just think about this. If you calculated one of these was bigger than the other, would it even have any effect? I know this sounds like I'm rambling, but I'm really doing some legit thinking right here. I might not like be talking a lot, but it's best for me thinking this way. Even if there was a way for me to like snap these. Man, I accidentally spilled some water. I will be a few minutes. Alright, I just realized as well. Can't remember if I can set the time to 0 and have it last forever. Yeah, okay. Yanka. Yanka hit 58 to 8. Oh man, what is this? Just gonna make the settings of this a little bit better. Okay, that should be good. Yeah, I feel like transform is the right word here. Okay, so I'm going to look at doing the second derivative. Just the simple second derivative using the state and the last state. So what it's going to do is it's going to do state minus last state index. So I'm going to need two states here. So then each time it does this, it's going to flip this state. Like that. Okay. See how that works. And that will fill them up fine. Oops, I made the same mistake as before. I started everything back up, didn't I? Okay, I did. Last state is undefined. That's right here. Oh, I forgot to add it. Something's wrong, it didn't execute. Not a number. So it starts out as not a number.
Can't stop running away.
It should just be 0, I think.
Can't stop running away.
Yeah, it is 0.
I walk too far to turn around. 'Cause if we don't give a fuck about each other, it's over. Oh, if we fall, blame it on the humans. Yeah, if we fall, who saves us from these ruins? We future, just computers. No one here to start a war. We're forgotten, just a picture. No one looks at anymore. In a world where we forget about our mothers, maybe we deserve to fade away. 'Cause if we don't give a fuck about each other, it's over. If we fall, blame it on the humans. Yeah, if we fall, who saves us from these ruins? Based a bit and we lost it all. We always thought we'd make the world better, but look at us now, we've fallen so far.